Hello students, nitrogen molecule and oxygen molecule. First, nitrogen molecule. We want to check the configuration of N2 molecule, whether it exists or not. Okay, so how will you identify whether the molecule exists or not? So first we have to identify the Z value. Z value is 7. So if it is 7, what is the configuration here? The configuration is 1s2, 2s2, 2p3. So if it is nitrogen molecule, two such atoms will combine and that will result in total of 14 electrons. So total number of electrons in the molecule is equal to 14. And so the molecular orbital configuration is written as sigma 1s2, sigma star 1s2, sigma 2s2, sigma star 2s2. Then comes pi 2px equal to pi 2py. Both are having the occupancy of 2. So total of 4 electrons will be there, followed by sigma 2pz2. Hope it is clear. So we have 2 plus 2 plus 2 plus 2, 8 plus 4, that is 12 plus 2. Total 14 electrons are arranged. Now we'll check what is the bond order. Bond order is equal to half of NB minus NA. So whenever we write the bond order, make it a habit that you use the formula first and then substitute the value, which is equal to half of NB. How many electrons are there in the bonding type? 2 plus 2 plus 2 plus 2 plus 2. So total 10 electrons are there, minus how many electrons in the antibonding? You have a total of 4. So that means you have the bond order to be 3. So since it is an integral value, this is a positive value, and the positive value indicates that the molecule is stable. And moreover, since it is having the integral value 3, it means that in between the atoms we have a triple bond. Now we have to check what is the nature of the molecule. The nature of the molecule can be found only after drawing the molecular orbital diagram. So we shall draw the molecular orbital diagram now. Energy level diagram for nitrogen. First, mark the energy. First we have 1s2, 2s2 and 2p3. Similarly, on the other side we have 1s2, 2s2 and 2p3. Show the formation of the molecular orbital here. So we have sigma 1s2, sigma star 1s2, followed by sigma 2s2, sigma star 2s2. Then comes pi 2px, pi to py, sigma to pz, followed by pi star to px, pi star to py, and sigma star to pz. So here we have total of 6 electrons left over to be arranged. So that we will arrange according to Hund's rule and Aufbau principle. Here we have total of 6 electrons, out of which 1, 2, 3, 4 will be arranged in pi orbitals, followed by the rest of the 2 in sigma to pz. So on examining the molecular orbital diagram, one can identify that all the electrons present are in the paired condition. That means nitrogen molecule is diamagnetic in nature. That is, it will repel the magnet. So you find that those which are having paired electrons in them, they will be weakly repelled away by the magnet, and they are said to be diamagnetic in nature. We'll try discussing the case with oxygen molecule. What is the atomic number of oxygen? Z value is equal to 8. So what will be the electronic configuration for oxygen? It is 1s2, 2s2, 2p4. And when oxygen molecule is formed, two such oxygen atoms combine together. With the result, the total number of electrons in the molecule becomes equal to 2 into 8, that is 16 electrons, which are to be arranged in the different molecular orbitals. So the molecular orbital configuration becomes sigma 1s2, sigma star 1s2. The next higher level is sigma 2s2, sigma star 2s2. Note that Z value is more than 7. So there is a slight change in the order of the filling up of the molecular orbitals. The next orbital that is filled will be sigma to pz square, followed by pi to px, which is equal to pi to py, because it is degenerate and it will be filled again. So 2 here and 2 here, total of 4 electrons are occupying there. The next higher level, we have pi star to px, which is equal to pi star to py. On checking the configuration, you find that we have arranged a total of 10 plus 4, that is 14 electrons in the different orbitals. So the leftover ones are only 2, and that has to be arranged in the degenerate orbitals. So it will be arranged according to Hund's rule. So you find that one electron will enter the pi star 2px and the next one in the pi star 2py. So total of 2 electrons will enter here. Now we shall calculate what is the bond order. Bond order is calculated using the formula half of number of electrons in the bonding minus number of electrons in the antibonding molecular orbital. Now, how many electrons are present in the bonding type? Half of 1, 2, 3, 4, 5. Total of 5 bonding orbitals are there, due to which you find the maximum capacity becomes 10 minus total of how many electrons are present in the antibonding. So you have 2 plus 2 plus 2, total of 6 electrons, so which will amount to a value which is 2. So bond order 2, it is an integral value which helps to understand that this molecule is stable and it has a double bond in between. Now we shall see what will be the nature of the molecule here. On examining the molecular orbital configuration, one is able to understand that there are two unpaired electrons in the antibonding orbital. So if there is a presence of unpaired electrons, such type of molecules will be attracted towards a magnet and it is said to be paramagnetic in nature. So you find that oxygen molecule is paramagnetic. We'll just draw the molecular orbital diagram to confirm it. So as proceeded earlier, here you are writing the different atomic orbitals on two sides and the molecular orbitals form will be centralized here. So you have the energy written and it is moving in the upward direction, and then we have the configuration of the first oxygen atom as 1s2, 2s2, 2p4. 1, 2, 3, 4. So total of 8 electrons are arranged. Now the next oxygen atom also has a similar configuration. So we'll draw 1s2, then 2s2, 2p4. We shall now represent the molecular orbitals and do the configuration. Now, 1s and 1s orbitals combine together to form sigma 1s to sigma star 1s2. So that orbitals are completed now. Coming to the next set, we have 2s combining with 2s resulting in sigma 2s orbitals which will occupy 2 electrons, and sigma star 2s which is also occupying 2 electrons. Coming to the 2p orbitals, which is the next higher orbital, here you find that the molecular orbital will be sigma 2pz, and next comes pi 2px, which is equal to pi 2py. So both are degenerate. Then comes pi star 2px and pi star 2py, followed by sigma star 2pz. Now we have to arrange the rest of the electrons present in 2p orbitals. How many electrons are there this side? This side you find 4 electrons are there, and the other oxygen also contributes 4 electrons. So total of 8 electrons are to be arranged. So that will be arranged according to Aufbau principle and Hund's rule. So here you find that the one electron from this side and the other electron from the other atom comes and joins together to fill up sigma 2pz. Now we have the rest of the electrons to be arranged. So we have total of 8. We have arranged 2 of them. So 6 are remaining. So now 1, 2, 3, 4, 5, 6. So all the 8 are arranged accordingly. So on analysis of the molecular orbital diagram, one is able to understand that in the outermost outermost orbital, that is the pi star to px and pi star to py, we find two unpaired electrons are present. So we find that if the molecule has unpaired electrons in them, they are capable of being attracted towards a magnet, and such a type of molecule is said to be paramagnetic in nature. So the nature of the molecule is paramagnetic. On analysis, experimentally also, oxygen was found to be paramagnetic in nature. Suppose you are given a molecule whose bond order has to be calculated. What will be the change that is to be mentioned? So here, if you have to find out the bond orders of O2 negative, first you have to follow all the steps that are involved till now. First, identify how many total electrons are present. You know that an electronegative atom has a tendency to gain electrons, and when an atom gains an electron, it becomes negatively charged. So here, oxygen molecule is gaining a negative charge, means it is having an extra electron. So total number of electrons in O2 negative is equal to 2 into 8 plus 1 extra electron. So it is having 17 electrons which are to be arranged. So what will be the molecular orbital configuration? Molecular orbital configuration will be sigma 1s2, sigma star 1s2, sigma 2s2, sigma star 2s2, sigma to pz2, then pi to px equal to pi to py. Total of 4 electrons will be arranged here. Then comes pi star to px equal to pi star to py. So we have arranged a total of 10 plus 4, 14 electrons. So remaining are 3 electrons which are to be arranged in these degenerate orbitals. Remember, we have to follow the Hund's rule. So we have to fill up half filled, and then it will be in the paired condition. So with the result, this will have 2 electrons in the first case and 1 electron in the second case. So what will be the bond order? Bond order is half of NB minus NA. So total number of electrons in the bonding molecular orbitals are half of 2, 4, 6, 8, 10. 10 minus how many electrons in the antibonding? 2, 4, 6 plus 1, 7. 7. So what will be the bond order? It is 3 divided by 2, that is 1.5. So as a result, you find that there is a fraction in the bond order. That means there is no perfect single bond or double bond here. So there is a chance of showing instability in the molecule. Thank you. Hope you have understood the concept. Remember, when a molecule gains one or more electrons, that much of negative is gained. So the species become negatively charged. On the other hand, if a molecule expels out one or more electrons, it will gain positive charges. Thank you.